All right, let's revisit the dot product a little bit. So if we have a vector A, and let's say that A is just in the xy plane, but I want to write it in 3 dimensions. So the z coordinate would be 0. And let's let B be expressed in the same way. So B is bx, by. 0. And let's go ahead and graph them and get an idea of what we're looking at. So we've got I'm going to draw this as though it's living on the paper, so on the plane. So X and Y. And we said that A and B are in the plane. So here's A. And what that means is this point at the head of A is AX, comma AY. The 0 for Z just means we're flat on the plane. We're not above it at all. And let's sketch B. So this point at the head of B is just BX, BY. And the angle that the two vectors make with one another is theta. The magnitude of A is its length. So the magnitude of A is the length of A, and the magnitude of B is the length of vector B. Let's remember what the dot product is. So if we have A dot B, the dot product is the X components plus the Y components. Okay, good. And let's look at, I can see that the magnitude of A, pardon me, the dot product of A and B is a scalar. So let's just see what that thing looks like if we square it. So we'll have AX, BX, plus, and I'm going to write this the way I should have before, AY, BY. And let's just remind ourselves how to find the square of a binomial. It's the first thing squared plus A times B times 2 plus B squared. So I'm going to use that rule to square this more interesting binomial. So I've got the first thing squared, AX, BX squared, plus first times second times 2, AX, BX, AY, BY, plus AYBY squared. All right. And let's go ahead and distribute everything. And I want to put all of this in alphabetical order just to make it prettier. So we've got AX squared, BX squared plus 2 times. I'm going to put the A's first, so AX, AY, and then the B's, BX, BY, plus AY squared times BY squared. And I'm just going to remember that on the side. One other thing, though, I remember that a different way to express the dot product is the magnitude of A times the magnitude of B times the cosine of the angle between them. Great. Oh, one other thing. The magnitude of a vector is the square root. Well, let's see. A is AX, AY. So it's the first component squared plus the second component squared, square root of all of that. Okay, alrighty. So we've got lots of potential things to use. I want to write the cross product. So the cross product is defined to be the determinant of, so cross products are always entities in 3 dimensions. So across the top, I need to put I, J, K, where I is 1 unit in the X direction, J is 1 unit in the Y direction, and K is 1 unit in the Z direction. And we're thinking of Z as up. Now we're going to write down the components of A. So AX, AY, 0, and the components of B. BX, BY, 0. One additional rule that we need is if we have the determinant of 4 things, this is the major diagonal minus the minor diagonal. And when we have a 3 by 3 rather than just a 2 by 2, we're going to have a pivot row. And I'm going to use this top row. You can use any row or any column, but it's really helpful with cross products to use IJK as our pivot. So first I'm going to write down that vector I. And now I want to ignore the row that I is on and the column that I takes up. So I can see I'm left with AY0, BY0. Now we're going to move over to J, and the signs always go plus, minus, plus, and if there was another row, we'd do a minus again. So I'm going to do minus J. So I'm going to, let's see, the row that J is on is this first row, so that's gone. The column that J is in is this middle column, and I'm left with AX over BX 0, 0. So AX BX 0, 0. And we've got plus, if we use our third pivot, I'm going to ignore the row that K is in and the column that K is in. So I'm left with the determinant AX, AY, BX, BY. And let's go ahead and multiply this out. Notice that if I use the rule A, B, C, D, the determinant of a 2 by 2 is the major diagonal minus the minor diagonal. If I use that rule, then I've got I times AY times 0 minus BY times 0 minus J times AX times 0 minus BX times 0 plus K times AXBY minus BXAY. So the cross product of A and B, well, what is anything times 0 is 0. We're going 0 in the X direction. We're going 0 in the Y direction. Our only answer, our only direction of the answer is in the Z direction. So I can write A cross B as the three-dimensional vector 0, 0, because we have I and J are both 0, and then AX BY minus BX AY. There we go. So our cross product of a two-dimensional, or two vectors that live in the plane. So two vectors like these that live in the plane is a vector that only lives in the Z axis. That's kind of cool. And we want to play with the magnitude of A cross B. Remember that the magnitude is the X component squared plus the Y component squared plus, well, this whole thing is the Z component. So we've got AX BY minus BX AY all squared, and we're taking the square root of everything. And 0 squared plus 0 squared is 0. And you're probably saying, hey, Ms. Nell, just let this square root and the square cancel, and we'll just have AX BY minus BX AY. But we don't want to do that. What we're going to do instead is square everything. We're going to square everything to get rid of the square root and keep this inner square. So we have the magnitude squared, the magnitude of the cross product squared, is AXBY minus BXAY all squared. If A and B live in the plane. Well, let's go ahead and multiply this out because heck, why not? So we said that the rule for squaring a binomial A plus B is A squared plus 2AB plus B squared. This time the second term is negative, so I've got first term AXBY squared plus 2 times first term AXBY. Second term is negative BXAY, then plus the last term squared, negative BXAY all squared. And now let's multiply everything out. So I've got A sub x squared, B sub y squared plus 2 times, let's put everything here in order, in alphabetical order, and let's bring that negative out. So we've got AX, AY, BX, BY, and the negative squared is positive, so then we just have plus BX squared, AY squared. And because I'm crazy this way, let's compare the magnitude of the cross product squared with the dot product squared. So we had ax squared bx squared plus 2 ax ay bx by plus ay squared by squared. That's similar to what we have here. I've got a negative 2 ax ay bx by, but I don't have any terms that have the same. I've got an xy bx ay, but I don't have an ay by. I've got an ax by, but I don't have an ax bx. So let's do the most enjoyable thing with math, add and subtract the things that we want. So I've got ax squared bx squared minus, because we didn't have that before, and I'm going to subtract it down here. Ax squared bx squared, and then plus, let's go ahead and put this one next, ax squared by squared. We had that already, so we don't need to subtract it off. Now I want to put this third term, so plus, I'm going to put the ay first. Ay squared bx squared. I already had it, so I don't need to subtract it off. But I'm going to add the fourth combination, ay squared by squared. That I need to subtract off. Ay squared by squared. And I already had a negative 2 ax ay bx by. Oh, this is pretty exciting. So we've got ax squared bx squared plus ax squared by squared plus ay squared bx squared plus ay squared by squared minus, let's factor the negative out of the next three terms so that we have ax bx, ax squared bx squared. I want to put the middle term, the 2 term next. So plus 2 times ax, ay, bx, by plus ay squared by squared. And this is exactly, remember where we got that? That was the dot product squared right here. So we can write this as minus a dot b squared. So that those last three terms are there. And I have one other pattern to look at. What kind of a product do we have if we have a plus b times c plus d? Well, it's easy to multiply this out. We can distribute a across c plus d. So ac plus ad. And then we can distribute b across c plus d. So bc plus bd. And notice what happens when all four elements are different. The product of the binomials is every single possibility. A times C, A times D, but we don't have A times B or B times A because they're in the same binomial. And then we have C times B, C times A, D times A, here it is, D times B, B times C, B times D. So all possible products, and let's look at this. These first four terms, we have ax squared, bx squared. We have an ax squared, by squared. We have an ay squared, bx squared, and an ay squared, by squared. That is exactly ax squared plus ay squared times bx squared plus by squared. And ax squared plus ay squared, that's the magnitude of vector A squared. Bx squared plus by squared, that's the magnitude of vector B squared. And let's remember that we said that there was, here it is, an additional way that we could write the dot product. We said that A dot B was the magnitude of A times the magnitude of B times the cosine of the angle between them. So let's write A dot B here as the magnitude of A times the magnitude of B times the cosine of the angle between them, and it's squared. And let's distribute this square, which is easy because everything inside is multiplied. So we've got the magnitude of A squared, the magnitude of B squared. The magnitude of A squared, I don't know why I put this, magnitude of B squared, and then cosine squared, theta. And now I have a common factor. I've got a magnitude of A squared, magnitude of B squared in both terms. So let's factor that out front. Magnitude of A squared, magnitude of B squared. If we take the first term and divide by the common factor, we're left with 1. Then we have a minus sign. If we take the second term and divide by the common factor, we're left with cosine squared theta. And I know you can't stand it. 1 minus cosine squared theta is, beautiful, sine squared theta. And what was all of this? We took the magnitude of the cross product and squared it. So this is equal to the magnitude of the cross product squared. Again, I've got 1, 2, 3 things multiplied, and they're all squared. So I can write those 3 terms as magnitude of A times magnitude of B times sine theta, all squared. On the left, we have the magnitude of A cross B, all squared. And now I can take the square root of both sides. All that does is strike out those squares. And we get another analogous formula for cross product. So we've got the magnitude of A cross B is the magnitude of A times the magnitude of B times the sine of the angle between them. And let's just put here at the same place A dot B is the magnitude of A times the magnitude of B times the cosine of the angle between them. So we've got a way to write cross product, or at least the magnitude of the cross product, and the dot product, both with magnitudes of the vectors and the angle between them. Let's go back to our sketch. And let's complete the parallelogram. I want to put B here at the head of A. And I want to put A here at the head of B, and its length is magnitude of A. And you know that the vector from the origin to the head is A plus B, but that's not where we're going right now. We're going to look at this parallelogram and reach back in your memory to recall that you can find the area of a parallelogram by multiplying the base by the height. So the height of our parallelogram is the perpendicular distance between B and the other side. And can we represent H using values we know? We know theta. We know the magnitude of A. Okay, I think I can do this. We know that which trig function connects theta with the side opposite and the hypotenuse. You got it, absolutely. We know that the sine of theta is h over the magnitude of A, and it's h I was trying to find. So if I multiply both sides of this by the magnitude of A, I've got the magnitude of A times sine theta. That's the height of the parallelogram, so that the area of the parallelogram, well, that's base times height. The base is the magnitude of B. The height, that's what we just found. That's magnitude of A times sine theta. And check it out. See if I can find the page that we did this on. Here we go. We said that the magnitude of A cross B is the magnitude of A times the magnitude of B times the sine of the angle between them, and the area of that parallelogram is the magnitude of A times the magnitude of B times the sine of the angle between them. So the area of that parallelogram is the magnitude of the cross product. It's just kind of a nice little connection. All right, well, I hope y'all enjoyed that, and have a great day.